Good day everyone, my name is Danipin and today I will be presenting my final year project titled Auto-Scheduler Optimize Task Allocation for Production Line Technician. This project is supervised by Associate Professor Dr. Wang Lipei. Auto-Scheduler is a data-driven system that replaces manual guesswork in maintenance ticket assignment. In current practice, manager may assign tasks based on experience or judgment. However, this may not fully consider technician skill, certification, availability, workload, and task duration. Therefore, this system automates the task assignment process by matching the maintenance ticket to the most suitable technician. Besides scheduling, it also improves response time through automated notification and support monitoring through dashboard, analytics, and workload heatmap. Next, come to the problem statement. The first problem is inefficient manual task allocation. In many production environments, maintenance tasks are still assigned based on intuition, experience, or simple rules. However, important factors such as technician skill level, certification, workload balance, and task completion time may be ignored. This can cause some technicians to be overloaded while others are underutilized. It may also lead to skill mismatch where the assigned technician may not be the most suitable person for the task. As a result, task completion time becomes longer and production downtime may increase. The second problem statement is delay communication and response. Task updates are often shared through manual channels such as email, messaging app, or dashboard chat. During peak hours or when many breakdowns happen at the same time, some task assignment may be missed. If there is no automated notification or alert, delayed tasks may go unnoticed. This directly affects maintenance response time and may increase machine downtime. The third problem statement is limited performance monitoring. Manager often depends on periodic reports or manual tracking. These reports usually show past performance, but they do not provide enough real-time visibility. Because of this, manager may not be able to detect workload imbalance early, identify bottlenecks, or understand maintenance pattern quickly. This limits data-driven decision-making and make continuous improvement more difficult. Based on the problem identified, this project has three objectives. The first objective is to optimize task allocation by minimizing max spend and balancing workload distribution to improve operational effectiveness. The second objective is to improve response time within the production environment by delivering real-time notification. The third objective is to monitor and visualize the performance through performance analysis and heatmap for real-time tracking of technician activities. Now come to the proposed solution that consists of three main modules. The first module is the task optimization and allocation module, which is the core intelligence of the system. It uses the MOSAHH algorithm to generate optimized task assignments. The second module is the real-time rule-based intelligent notification and alert module, which ensure assigned tasks and alerts are delivered to technicians in real time. The third module is the performance tracking and visualization module, which provides dashboard and analytics to support monitoring and continuous improvement. Let me introduce the first module in detail. The multi-objective simulated annealing-based hyper-heuristic algorithm will take two main inputs, which are maintenance ticket and technician profile. The maintenance ticket include alarm codes, duration, and other details, and the technician profile will include information such as job title, certification, availability, and workload. Then the algorithm will generate an optimized task assignment result. The MOSAHH algorithm considers two main objectives. The first objective is workload balancing. This is done by calculating workload variance to ensure the tasks are distributed more fairly among technicians. It helps prevent individual technicians from being overloaded. The second objective is max spend minimization. Max spend means the total time required to complete the whole batch of maintenance tickets. By reducing max spend, the system can improve overall maintenance efficiency. Therefore, the system supports multi-objective decision-making by considering both workload balance and max spends. The second module is the real-time rule-based intelligent notification and alert module. This module monitors ticket status and sends timely notification to technicians across different devices. The purpose is to ensure that assigned tasks are received quickly and acted on as soon as possible. This helps reduce maintenance delay and improve communication between the system, manager, and technician. In this module, the ticket status can be categorized into unassigned, pending to start, attending, and completed. Once the optimization process is completed, email notifications are automatically sent to newly assigned technicians. This means that no manual intervention is required from the manager to inform each technician. The system also can support rule-based alert when tickets are pending or delayed. This helps to prevent important tasks from being forgotten. The third module is the performance tracking and visualization module. This module presents performance data through the performance page. It includes technician workload distribution, task status, optimization result, algorithm execution time, and workload heatmap. Through this visualization, manager can monitor task allocation outcome, identify workload imbalance, evaluate scheduling effectiveness, and support data-driven decision-making. This slide shows the overall system module structure. For task optimization, the system includes the ticket database, technician profiling and availability manager, MOSAHH optimization model, task distribution, and task rescheduling. For the notification, the system includes event detection, monitoring, and notification dispatch. For the performance tracking, the system includes performance analytics and activity heat map generation. This is the system architecture. The system is developed as a web-based application. The front end is built using React. The back end is built using Fast API. The optimization engine is implemented using MATLAB, where the MOSAHH algorithm processes the input data and generates the scheduling result. The Supabase acts as a database to store all information. Overall, the system architecture supports an end-to-end workflow from ticket data input, optimization, notification, and performance monitoring. The value of this system is not only the algorithm result but the complete workflow from decision making to execution monitoring. First, it supports smarter scheduling through multi-objective optimization. The MOSAHH algorithm minimizes max span while balancing workload, so the system avoids overloading the technician. Second, it helps reduce manual scheduling bias and human error. Since the system checks technician skill and certification, tasks can be assigned to more suitable and qualified technicians. Third, automated alerts help prevent tasks from being missed or delayed. Managers do not need to manually follow up every assignment frequently. Another benefit is data-driven management. Through dashboard and heatmap, manager can view workload distribution, technician performance, and possible bottleneck more clearly. This allows them to make proactive decisions instead of only reacting after problem happen. Lastly, the system is also resilient against human dependency. Even when a manager is absent, the system can still support task scheduling and notification. This can reduce the risk of delay caused by relying too much on manual assignment. Now move on to entrepreneurship opportunity. This project can be also positioned as a practical industrial software product for smart manufacturing and maintenance operation. The key selling points are reducing downtime, improving workforce utilization, and supporting multi-objective decision-making. One of the opportunities is to offer the auto-scheduler as a SaaS or cloud-based platform for factories that still rely on manual scheduling. Another opportunity is to sell the optimization engine as an integration module for existing systems such as CMMS, MES, or any internal maintenance system. For consulting and customization, the system can be deployed and customized based on different factory requirements, especially in semiconductor, electronic, and manufacturing plants. The same scheduling logic can also be expanded beyond manufacturing. For example, it can be applied to hospital maintenance team, facility management, logistics lead, and field service operation. The total addressable market can be global manufacturers that still using the manual scheduling. The serviceable available market can be Malaysia, E&E, and semiconductor sector, and the serviceable obtainable market can be Penang-based factory as a beachhead market. So now I will proceed with the project demonstration.
First, I will log in into the system under the manager role. After logging in, I will go to the account detail page. This page displays the user personal detail and job title. From here, the user can also toggle the button to update their availability for task assignment. Next, I will go to the dashboard page. This dashboard gives the manager an overview of the current task allocation status. Next, I will demonstrate the ticket creation function. On this page, the manager can create a new maintenance ticket by entering the ticket detail. The system automatically adds extra 5 minutes to the estimated ticket duration as an overhead buffer for preparation, handover, communication, and movement, making the scheduling result more realistic for actual maintenance operation. After creating the ticket, I will go to the scheduler page that serves as the system optimization engine. Here, the ticket created just now appear in the live unassigned queue. The optimization engine monitors this queue and can automatically trigger the optimization process every 30 minutes when unassigned tickets are detected. Besides that, the manager can also manually trigger the optimization from this page.
First, I will show case scenario 1, which is used to demonstrate the system ability to schedule a batch of maintenance tickets. In this scenario, I will upload a txt input file that contains the ticket details. The input file follows a specific format. The first line represents the total number of tickets. After that, each line contains the ticket ID, alarm code, target group, and estimated duration. For this case, there are 7 new arrival tickets and 50 available technicians in the system. After I upload this file, the system will read the ticket information and use it as the input for the optimization process.
Once the file is uploaded, I click the Optimize button. The system will then send the ticket data to the backend and the algorithm will be executed. After the optimization process is completed, the result is shown in the system. The assigned tickets are displayed together with the selected technician. Each technician receives tasks based on matching criteria. Now we move on to the task to do page. On this page, the assigned tasks are grouped based on their current status such as pending, attending, and completed. For demonstration, I will update the status of 2 tickets. After updating the ticket status, I will go to the ticket page. Here we can see that the latest status have been synchronized with the database. Next, I will show the technician registry. This page stores the technician profile including their job title, current workload, and availability status.
Next, for the second demo, I will show how the system handles rescheduling when there are existing tickets in different status. In this scenario, 4 tickets have already moved into attending state, where there are 4 pending tickets and 9 new arrival tickets. So the only pending, unassigned, and new ticket will be included in the rescheduling process. Tickets that are already attending or completed will not be rescheduled because they are already being handled or finished.
So I move these 4 tickets into attending and complete state. Next, the second input file is uploaded into the system. The optimization engine will only schedule the new and eligible tickets. Now the optimization process is completed and this is the result of optimized task allocation for all the tickets.
For the last case scenario, I will show how rescheduling works without adding any new input ticket. In this scenario, the number of available technicians is reduced to 8. This represents a real-world situation where some technicians may become unavailable due to shift changes, leave, or other urgent tasks. The system will then reschedule the remaining 11 tickets based on the updated technician availability.
So I move extra 2 tickets into the attending and complete state. Next, go to the technician registry page to toggle the availability button to decrease the number of available technicians from 15 to 8. Next, I click the rescheduling button. Once the rescheduling process is completed, the updated assignment result is displayed. Next, I will show the notification module. Once the optimization process is completed, the email notifications are automatically sent to newly assigned technician. So these are some emails that trigger automatically. Lastly, this is the performance dashboard. This page visualizes the system performance and optimization result. It includes metrics such as backend execution time, algorithm elapsed time, workload variance, and maintenance for each run. The system also includes a technician workload heatmap by status. This allows the manager to quickly identify which technician have more pending and attending tasks. Now, I will log out from the manager account and log in using the administrator account. The administrator and manager account have similar access where they can view most of the system pages and manage the scheduling related function. After that, I will log out again and log in using a technician account. Compared to the manager and administrator, the technician has the least access. The technician can only access the pages that are relevant to their work.
That's all for my presentation and live demonstration. Thank you.